Like I said, all that we're doing today is we're writing the null and the alternative. This is the step H in phantoms, writing the null and the alternative. Okay, we are going to start out just listening, not writing down. So I'm going to tell you how a hypothesis test works, and then you're going to write. So don't write right now. The way I'm going to explain a hypothesis test is like a court of law. So what do they assume if you go to a court of law? So if you are being tried for something, what is the initial assumption when you walk in the door? That you are not guilty. Okay, so this is called the null hypothesis. It's what is initially assumed to be true. So in a court of law, you are assumed not guilty. And then, what do they look for evidence in favor of? What do they try to prove?
That you're guilty.
That you're guilty. Okay, so that's the alternative. So the null is what you assume to be true. The alternative is what you look for evidence in favor of. So you have some evidence. So we initially assume that you're not guilty, and then we find all this evidence to prove the opposite, that you are guilty. In the case of a hypothesis test, that means that you reject the null, and you instead believe the alternative. So enough evidence has been shown to believe the alternative. Okay, so this is the same thing. Again, we're assuming that you're not guilty, looking for evidence to the contrary. Okay, so sometimes we assume that you're not guilty, and then we only find a little bit of evidence that you're guilty. In this case, what does the court of law say? What's the final verdict?
You're not guilty.
That you are not guilty. This is called failing to reject the null. So failing to reject the null means you didn't have enough evidence for the alternative. It does not mean that the null was proven true. So are you ever proven not guilty?
No.
Or proven innocent? No. They try to prove you that you're guilty, but they didn't find enough evidence. That's the way a hypothesis test works. Okay. Now we are going to start writing. Here are the important things for you to understand. HO is the null hypothesis, and it's the initial assumption. So HO is the null hypothesis. It's the initial assumption. HA is the alternative hypothesis. It's what we look for evidence in favor of. So you always look for evidence in favor of HA, never in favor of HO. Really, what's most important in a hypothesis test is HA. You look for evidence in favor of HA. And then you either have evidence in favor of HA, or you don't have evidence in favor of HA.
It's the alternative what?
Hypothesis. Okay. So your decision is made in terms of the null. So in an actual court of law, you are found not guilty or guilty. You are never found innocent. Your two possible conclusions are that you fail to reject the null or you reject the null. Okay. Case number one where you reject the null. If you reject the null, you found evidence for the alternative. Write that down. So case one, the first possible conclusion is that you rejected the null, so you found evidence for the alternative, or you found sufficient evidence, significant evidence. Case one, you reject the null, you found evidence for the alternative. Case two is that you fail to reject the null. In the case of failing to reject the null, you do not find sufficient evidence for the alternative. So you found some evidence for the alternative, but not enough to believe that the alternative is true. So again, fail to reject, you do not find sufficient evidence for the alternative. Found some, but not enough to doubt the null. Is that clear on the general idea between the null and the alternative hypothesis? Or hypotheses? Okay, I think it's easiest to see this if we just jump in and do an example. So we are going to do the first example together. It says a certain TV station has been providing live coverage of a particularly sensational criminal trial. The station's program director wishes to know whether more than half the potential viewers prefer a return to regular daytime programming. A survey of randomly selected viewers is conducted. Let pi represent the true proportion of viewers who prefer regular daytime programming. What hypotheses should the program director test to answer the question of interest? Okay, so we are writing the null and the alternative. First thing that you need to know is you will be writing these two ways, once in symbols and once in words. In symbols, it always has to be in terms of a population parameter. So your hypotheses are always going to be in terms of like pi or mu or sigma squared, anything that's a population parameter. In this case, we are told that we are using pi. So they're both going to be in terms of pi, population proportion. Next thing you need to know, the null is always a statement of equality. So it's always going to be the parameter equals some number. The alternative is always a statement of inequality. So for the alternative, it can be greater than, less than, or not equal to. Okay, so the question of interest is whether more than half the potential viewers prefer a return to regular daytime programming. So you have to remember that the alternative is what we are looking for evidence for. So we want to know, do more than half of the viewers prefer the change back to regular programming? So our alternative is that pi is greater than 0.5. So this would indicate that more than half of the potential viewers prefer a return to regular daytime programming. Whatever the number is for HA, HO has to be the same number. So these are always going to be the same. So this is the null and the alternative in symbols. We're also going to say what that means in words. The alternative is easier to write in words, so we're going to write that one before the null. So if pi is greater than 0.5, that means more than half of the potential viewers prefer a return to regular daytime programming. Okay. I think you all read about this, maybe, hopefully. But here's the most confusing part, is the null. The null is always the opposite of the alternative. What is the opposite of greater than?
Less than or equal to.
Less than or equal to. So that's really what the null is understood to be, but we don't write it like that. We write the null always as a statement of inequality because it makes things easier. So in our minds, we wrote pi equals 0.5, but really the main assumption is that pi is less than or equal to 0.5. So I tend to write my null as the opposite of my alternative. Or not really the opposite, as not the alternative. So if the alternative is that more than half prefer a return, the null is that it's not true that more than half. So it's not true that more than half of potential viewers prefer a return to regular daytime programming. I know that it doesn't sound very nice, but I think it's the most correct way to say it. The other way that you could say is at most half of potential viewers. You cannot say exactly half, because although that's the way it's written, that's not the way it's understood.
Would it less than or equal to half of the potential viewers? Would that also be correct?
That would also be fine. Okay. You guys ready to try an example?
Sure.
Good. Next one, you guys are trying. Sure, with your partners.
Manufacturer of
Anything. It's lower than 40 decibels when I'm playing. Required replacements to higher than 40 to manufacture may be liable for damage to an electrical system as a result of fuse malfunction. Having mean rigid hinges.
So we would want it to be,
sample fuses selected.
can we do like between?
What Null alternative hypothesis would be of interest?
So, no. You would assume
It's not two different.
mu.
They have what are these?
Do we have to write
Well,
this?
so your first statement. So it's either lower than 40 or 40.
That's what we are assuming.
Oh, okay.
Greater than 40? So it's not.
The null hypothesis is like highs for sure.
So it would be, it is not true that the mean amperage is
So
40.
when it talks about higher, the amperage is not 40.
I think it, what's
So it is not true that the mean amperage,
why don't you do it?
what?
Because it's easier to figure it out.
And the first employee is
Hold on. Hold on, it's easier to do this. So this is
the null
equals 40. Or
the first unit amperage or
I think Amos is the event amperage.
Do we do
Your option for less than, greater than,
yeah, it's fine.
third option.
HA is the mean amperage. And the other one is not true. It's not a mean average. Can we say like it's less than 40 is not true?
Probably after bottom. Is that why you said, yeah, was yours one?
How much overweight?
We decided to be 100 with batteries or without batteries and then 100 with batteries. So like it's not.
You mean you decided to be?
Okay, let's go over this real quick.
We decided for the weight limit to be 100 with batteries.
But they include batteries.
So it's like
Wrong.
14.
Okay, so my first question is, what symbol did you use? Mu. Okay, good. Mu. So this one is obviously mu equals 40. 40 is the only number, has to be a statement of equality. What is the inequality for the alternative? It's not equal to 40. So greater than is dangerous, less than is dangerous, or they're bad for the company. So not equal to is what we are testing. Okay, so we are assuming safe, looking for evidence to the contrary. So the alternative in words would be the mean amperage
Yeah.
Magic.
is not 40 amps. Okay, and then I told you that the null sometimes has an alternate meaning. What is the opposite of not equal to? Equal to. So that's exactly how it's understood. I told you to word the null as the opposite of the alternative. In that case, it would be, it's not true that the mean amperage is not 40. Which I really am not a fan of. So this one, I would word it as the mean amperage is 40. Yes.
Is it okay if we put population in the average?
That's beautiful. I should have done that.
Don't touch my shoulder.
Okay, how do we feel about this?
Okay.
Not bad?
Thank you.
Okay, would we like to step it up a notch? Mind you, the answer is yes, 'cause I'm going to do it anyway, so. Okay, so we're doing the example on page 9.
Oh, no secrets. Yeah, why can't we go to secrets?
Because I like this example better. Okay, so first of all, I change all the 6s to 7s. So go through right now on your page 9 and change 1, 2, 3, 4, 5, 6. 6 6s to 7s.
Wait, why?
But not in the sample.
Why do we need to change it?
Because. Just do it.
What?
And we'll change the results.
What are we changing?
All the six.
My God.
Except for the one on the center for you.
Where were you?
Oh, I thought you meant like.
Now you know what it's like for me every day. Okay, so thank you. Okay, our residents in a particular city is safe from exposure to household radon gas. So it says the city standards for radon call for no more than a level of 7 parts per million. From these data, does it appear that the mean radon level for city houses is under 7? Okay, so we want to know, are people safe or not? If the level is 7 or below, they're safe. If it's above 7, they're in danger. So this is our null, is that mu equals 7. So that means and then the alternative is that mu is greater than 7. Okay, so our alternative is that mu is greater than 7, which is a dangerous level. The null is really less than or equal to 7. It's the opposite of greater than. So really we're assuming that the city is safe, or the city's radon level is safe. We're looking for evidence to the contrary. Okay, this is not a full phantoms, it's just the general idea. So mu is population mean. So then we took this sample of size 10. So without knowing anything about a hypothesis test, what do you think you should do? Just to start off with.
Check the assumptions. Define the parameter.
Calculate the sample mean. So do that right now. You have a sample, calculate the sample mean. If I were you, I would put this information in the list.
X bar is 7.7.
Okay, while they're working on that, find the standard deviation too.
Okay. 3.7 squared is 13.69. 13.69.
Robbie, where is your calculator?
0.3, which is
Right there.
0.09.
Get out.
This is this way.
7.7.
Okay,
Find 53 squared.
did we get X bar to be 7.7?
28.9.
Yes.
Alex, could you do me a favor and just stop talking because you're distracting people because they want to listen to your calculation. So, stop talking. Okay, so this is the situation we're in right now. We are assuming that mu is 7, but we got an X bar of 7.7. Okay, is that possible to have mu equal 7 and get an X bar of 7.7? Is that possible?
We don't know.
It could be possible.
Okay, so
If it could be possible, then possible.
It's not inclusive.
It depends on the situation.
I mean, you could assume it's
okay,
possible.
okay. I'm sorry. Let me ask a different question. Let's say that the true population mean age at Prospect is 16.2. Is it possible that I take a sample and I get a sample mean of 16.4?
Yeah.
Yes.
Yeah. 16.8.
No.
Yeah.
I didn't tell you my sample size. My sample could be size 3. Is it possible that I get a sample mean of 21?
No.
Probably not, right?
Super senior.
Teachers allowed in the sample.
No.
That's kind of it.
Okay, probably not. How do you figure out where the cutoff is between what's likely and what's not? That's the question. So that's what we're going to be doing now. So we want to know what's the probability of getting that sample mean of 7.7 if the population mean is truly 7. Now, in a continuous distribution, you can never calculate a probability at one specific point. So we're going to have to do this as a range instead. So we're going to calculate the probability of getting x bar that's at least 7.7. Because we can't calculate the probability at one specific spot. It's got to be a range. Okay. So the only way that we can do this is if we know something about the sampling distribution. So x bar is the sampling distribution. We have to know the shape. Basically, it has to be normal. How do you show that the sampling distribution is approximately normal?
No.
Same thing.
You could do a box plot or
Central limit.
central limit theorem, or the population is normal. Is the population normal in this case? We don't know. Is the sample size big enough?
No.
No. So we would have to draw a box plot. We're not actually going to.
That looks pretty
I'm just going to tell you that the box plot has no extreme skewness for outliers. Fair?
Fantastic.
Okay, so then at this point, this becomes a z. So we're going to do 7.7 minus 7 over, this is where you need to be careful. Here, we need the standard deviation of the sampling distribution. How do you find that? It's not the same as S. S is the standard deviation of the sample. I want the standard deviation of the sampling distribution. Come on, guys.
10 minus 1.
It's in the panic formula for mean. The panic formula is x bar plus or minus. It's not the x bar. It's not the plus or minus. What comes next?
Z.
T.
T.
It's not T. What's the last part of the formula?
S over.
There we go.
Didn't we,
That's. Why didn't you just
didn't we
write?
say that?
I did not hear it. No.
We said that.
Never mind.
I heard square it.
Yeah,
I heard
did a lot
use
of
the
writing. I did a
calculator.
lot of writing.
Why didn't
Okay.
you just write S?
Because this is the true formula. Now, we don't have sigma, so in this case we're going to have to use S. So if you look on your calculator, I got an S to be 2.98 divided by the square root of 10. Okay, so do that, but use the stored value, of course. I don't want you to actually use 2.98.
I almost got S.
So I got 0.943.
Of course.
Okay, so that's the standard deviation that goes here. So then you're going to calculate that z-score, of course using the full 0.943 decimal, not just 0.943. So that gave me a z-value of 0.742. Okay, so now how do I find the probability that z is greater than or equal to 0.742?
Charts.
Normal CDF. Or the table if you prefer the table.
What was the value?
2.771.
I got about 2.229.
Pretty close.
Yeah.
That's what I said.
Not that far off. And so I just
Okay,
for 0.8.
are you all with me?
Yes. What was this for? 0.943. See, Miss Button, I got it.
I didn't subtract.
Good.
Okay.
Okay, So that is the probability of getting a sample mean of 7.7 if mu were actually equal to 7. So about 23% of the time, you're going to get a sample mean of 7.7 or bigger if the population mean is 7. Is that fairly likely or very rare?
The former.
It's fairly likely. What's the rule of thumb for what's rare? 5%. We're bigger than 5%. So do we have evidence in terms of the alternative?
Yes. Yes.
You would have evidence for the alternative if this sample mean was very rare.
Oh.
So in this case, do we have evidence for the alternative?
No.
No. Okay, if you do not have sufficient evidence for the alternative, what is your conclusion?
Innocent.
Failed to reject.
Cadence.
Okay, so we're going to write a conclusion. So I fail to reject the null. Does that mean that I believe the null?
No.
No, it means there's not enough evidence for the alternative. So I fail to reject the null because there is insufficient evidence that the population mean radon level is above 7 parts per million. Okay, to this town, what does that practically mean? We think that the people are safe. Practically. Natalia?
What order do you put the things in for normal CDF again?
Lower bound, upper bound, mean, standard deviation. Yes, Roger.
I don't understand why we're failing to reject the null in this situation. Because it's likely to assume that it could be 7.7, right?
It's like reversed.
Like
No, so-
23% of the time it could be 7.7, which
We don't have sufficient evidence.
23% of the time, if mu is 7, you'll get a sample mean of 7.7.
Oh.
So that's pretty likely. So we think that, yeah, mu is probably 7.
okay.
So if you got a really small probability, like if we got a probability of 0.04, that would mean that we got 7.7 when the mean was 7, like a really, really small percentage of the time.
Oh, so
In
that
that
means
case.
that the mean wouldn't be okay.
Right.
That makes sense.
Okay. Any other questions before we move on?
Would it be like considered like small enough to like accept it like under like 10%?
0.05. 5%, yeah. Okay. No, we're good? So this is the basic idea of a phantom, except,
Like 1200?
yeah, a lot longer.
How many points would that get you on the pen? Like 5?
5. Okay. First thing you need to know. Questions 3, 4, and 5 are due tomorrow. So this is off of homework.